Hello everyone. Hope you're having a great day wherever you are again. And today, this is going to be a follow-up video to the first smart contract tutorial we did. In that first video, you'll notice that the counter tool we created was incrementing things by 2, even though we wanted to just do it by 1. And so I'm creating this second one just to kind of follow up and put some corrections to that first edition. Again, if you'd like, please check out some of our previous videos. We do a lot on financial education and program tutorials. But again, in this video, we're going to be checking out a little bit about Solidity and using Solidity again on the Ethereum blockchain. So without further ado, we'll kind of just jump into some of the hard actions we'll need to complete in Remix. So first, what we'll do is we've created a file called our counter.sol that is here in our file workspace. And we're going to go ahead and move our contract that we've created again. We talked a lot about using OpenAI tools, so feel free to jump into documentation like this for Solidity in combination with tools like OpenAI to kind of get you started writing your first smart contract. So I've laid out some of the steps here and again, some of the components that, some of the pieces that make up the smart contract. And we're going to just go back down here and copy our contract here, and we'll explain it once we get it into Remix. So before we compile it, we'll just kind of go over some of the fine details. The smart contract is called my contract, and it allows you to increment and decrement the variable x. Here's a breakdown of each piece of the smart contract. The top part you see there, the SPDX license identifier, that is a license identifier that specifies the license under which the smart contract is distributed. In this case, it is licensed under MIT. That next part you see is the Solidity version number. This specifies the version of Solidity compiler to be used for compiling the contract. In this case, it's version 0.8.18. That next part you see in the contract is the my contract name. This is the declaration of the contract named my contract. The next part of it is the integer public of x. This is a public unsigned integer variable named x. It is declared as public, which means it can be accessed and read by other contracts or external entities. The next one is the function increment. This function named increment is declared as external, which means it can be called by other contracts or external entities. This function increments the value of x by 1. And you can see there 1. The next part of the code here, x plus equals 1. This line of code increments the value of x by 1. This next line, function decrement external. This is a function that named dec as it is declared as external, which means it can be called by other contracts or external entities. This function decrements the value of x by 1. And again, you can see it here because it's minus here and plus there. So again, in summary, this smart contract provides a simple way to increment and decrement the value of the variable x by calling their respective functions increment and decrement. The current value of x can be accessed by reading the public variable x. And so just to kind of go over what what the previous smart contract that we used, it was a little bit more complicated, and we didn't need some of the stuff in it. However, this will still function, and it will function correctly as long as we're in the right environment. And that's the main issue that I wanted to correct as a kind of a follow-up in this video. So again, we're checking our Solidity version here. It's the same version, and we'll compile it. Next, go ahead and clear everything out, make sure it's nice and clean. We'll make sure we're in the JavaScript virtual machine. This is the Remix virtual machine merge. There's a number of different ones, but the one that we want to be on is merge. We'll deploy the contract. No problems. Open it up. Check the total amount of X. Decrement. Decrementing will fail because we are already at 0. So we'll increment it by 1. Check it. The value is 1. So again, we just needed to be in the correct environment and have a little bit of a revised smart contract just to simplify the need that we had today. It's just a simple counter contract. So I decided to go back and review some of our materials here, here, and here. And with the AI's help, I was able to get a little bit more of a simpler version, in addition to some of the great friends that I have online ask questions too. But again, thank you so much for checking out this video. As always, there is more to learn. Feel free to check out the ethereum.org website, as well as the docs.soliditylang.org website for plenty of good educational resources and documentation. And until next time, I hope everyone has a great rest of the day. Take care.